Good morning, children. As we have already discussed about the reflection of light in 7th and 8th standards, we are going to learn about one more property called refraction of light. Light at plane surfaces. So, let us know first about the property of refraction. So, reflection, when light falls on an opaque body and it comes back to the same medium, then we call that property of light as reflection. That means when the light cannot pass through something, it will be reflected back. That is called reflection. So here refraction is light can pass through the other medium. Let us say from air it is passing through glass. From air it is passing through water. From air it is passing through any other fluid like oil or glass to water, glass to air. Then we call that property of passing of light. Okay, so light has ability to pass through one medium to another medium, and this property of light passing from one medium to another medium is called transmission of light. So light is transmitting from one medium to another medium, and during this process light deviates from its original path when it travels from one medium to another medium. So here the two mediums that they are passing through must be a transparent mediums. Transparency means which allows light to pass through, something to pass through them is called transparent. So light is traveling from one medium to another medium, two transparent mediums. So these two transparent mediums will have different densities, different thickness, different molecular arrangement. So because of that molecular arrangement in these two mediums, we will have the light to be deviated at the separation of these two layers. Okay, part of the layer of separating these two mediums, and at this property of light slightly bending at the separation of the two mediums is called as refraction. Light undergoes refraction at not only plane surfaces, even the curved surfaces. But in this topic we are going to learn about what are the properties, why it is undergoing this bending or deviation, that we will be studying in this video. So here coming to observing why it is bending, why it is taking place, let us do a small diagram. So let us say this is the separation of two mediums. Let us say here water is there and here air is there. So the density of air molecules is less. Density, low density medium, and here it is high density medium. Okay, so air is low density medium, water is high density medium. When light ray travels from lower density medium to higher density medium, so if this is a separate okay, plane of separation. So here we call it as normal. A line drawn perpendicular to the plane of surface is called as normal. At this normal, this ray, so everywhere you will have different normals here. So any ray which is traveling from one medium to another medium, it undergoes a slight deviation from its original path. Actually, it has to travel like this. But instead of traveling like this, what does it do? It will be traveling towards the normal. It bends towards the normal. Got it? So it is bending towards the normal. Slightly it bends towards the normal. So it deviates from its original path and it will be traveling in this path. And this property of light bending at the separation of two mediums is called as refraction. So how it is taking place? What is the responsible factor behind this? In order to understand this, we have to know some properties of these mediums and property of the light in different mediums and all these things. That's what we are going to study here. Let us coming to the topic. Here, air is a less denser medium. In the low density, when the density is less, the light velocity of light will be more. When the density is more, the velocity of light will be less. So, when light entering from low density medium to high density medium, the rate of speed of the light will be decreasing. As it is decreasing here, because of the decrease in the velocity makes that light to slightly bend at the separation, and this property of bending, okay, depending on a certain ratio, that is speed of light in vacuum to speed of light in the medium. Speed of light in vacuum to the speed of light in the medium. So here vacuum, or it can be air also. Air and vacuum, it is same. So the speed of light in vacuum to the speed of light in the medium, if you observe this ratio, we call this ratio as refractive index. Refractive index. Generally, this refractive index is represented by letter N or mu. Any of these letters can be used to represent this light. So, when the refractive index of one medium is compared with the refractive index of the another medium, so this is called absolute refractive index. When two mediums are compared with one another, so we call relative refractive index. So since refractive index is the speed of light in vacuum to the speed of light in the medium, this do not have any unit. Since it is a ratio, ratio of something does not contain any unit. So here two similar quantities, so the units of the first quantity and the units of the second quantity will be cancelled. Meter per second are the speeds units, so they will be getting cancelled and you will be having no unit for the relative refractive index or refractive index. Got it clear? Thank you.